Welcome to Electrical Knowledge Box. Today we will study how a power will form its requirements and its existence. Now details we will study today class. Now this is this power. Power is the capacity of work done. Capacity of work done. We known as power. Okay, it is denoted by the symbol. It is denoted by the symbol P. Now in electrical engineering, unit of power is in electrical engineering unit of power is watt, kilowatt, megawatt, gigawatt, and so on. Let us try. Now first we will discuss apparent power. Next we will discuss active power. Next we will discuss reactive power. Now first we will see what is a apparent power. Apparent power. Now this apparent power is the multiple of voltage with current. This is your power. Now in case of this is in case of DC circuit. Now this is your angle between this power. If you see in a graph, suppose this is your voltage axis, this one is your current axis, then this graph becomes parallel. That means cos phi equal to now 1 for resistive load, phi equal to cos inverse 1, that is equal to 0 degree. Now here angle between voltage and current becomes 0. It can happen in DC circuit or network. It can be possible in resistive load only. It can be possible resistive load only. Second is your active power. In every operation, active power is required, or we can call real power. Now here in this case, power is multiple of voltage, current, and another factor, that is power factor. P equal to multiply of voltage, current and cos phi. Cos phi is your power factor, that is voltage angle between current and voltage. We can call this is called also true power, correct? Now in this in case of AC circuit, for single phase power equal to voltage multiply with current with power factor. In case of three phase, we call line here, three phase power equal to root 3 V line voltage, line current, power factor. In case of phase, power equal to 3 VPH, IPH, cos phi. Phase voltage means, what is phase voltage? First we will see phase voltage, and another one is your line voltage. Now if you draw three lines, suppose we will draw, suppose this one is your R, Y line, B, and this one is your neutral. Now if we see phase voltage, that means any line to neutral, that is VR, R phase, another line to neutral, that is VY phase with respect to neutral. You can also write RN, YN, B to N, we can write BN, that is B phase, this is Y phase, this is R phase. Understood? Next, suppose another three lines you draw, one is R, Y, B, N. Now R to Y, that is line voltage between R and Y, RY. R to B, this is your line voltage between R and B, R to Y to B, this is your line voltage between V, YB. Now three line voltage, and here also three phase voltage. Reactive power 0.3, reactive power. Reactive power, it is denoted by the symbol Q. Now reactive power equal to voltage multiply with current, another factor, that is sin theta, that is angle between voltage and current. It is also called imaginary power. Now with the example we can clearly understand what is the imaginary power. Now we will take a example. Now let's take a strip, metal strip. Now a coil wound over it. Now like this, a coil wound over it. First end we will take, another end we also take, and supply a AC source. When you supply a AC source, then a current will flow in this circuit. Let it be current I. Now when supply connected, the current will flow only in this coil. Now energy developed in the circuit is E equal to half Li square. This is your energy developed in the circuit, where E equal to energy, L equal to inductor coil, I equal to current flowing through the coil. That is current, we can write. Correct? Now in this circuit, if you understand every cycles, let's draw a AC cycles, one cycle, and it's a respective. This one is your positive wave peak, this one is your negative cycle peak. This one is positive peak, this one is your negative peak. Now if you see in first quarter, this one is your first quarter. Now we will, this one is your first quarter. In first quarter, the inductor store the energy. Inductor store the energy. Here current increases in this first quarter. In second quarter, this is your second quarter. In second quarter, the energy store decreases. Energy stores decreases. That is supply back to the voltage source. We can say supply back to the voltage source. This one is your second quarter. Now if you see in third quarter, what happens? This one is your third quarter. In third quarter, the inductor also store energy. Inductor store energy. Here current also increases, in this case decreases. Now if you see what happens in fourth quarter, now you draw first. This one is your fourth quarter. In fourth quarter, energy stored by the inductor decreases again. Energy stored by the inductor decreases. Understood? First quarter increases, second quarter decreases. In negative third quarter, that is inductor energy store again it is decreases, that is current again decreases. Now if you see, we can compare with capacitor. If we compare with capacitor, then we see inductor consumes reactive power, and capacitor generates reactive power. Understood? Now another points, so energy exchange between two elements. So energy exchange between two elements. Another point, no true power is consumed or generated. No true power is consumed or generated, because in every cycle, every half cycle, every cycle, you can see that energy becomes zero. No power in finally we will get. So no true power is consumed or generated, we can say. Fourth point, so reactive power is called imaginary power. That's why we called reactive power is called imaginary power. Imaginary power. Thank you very much for watching.